Good morning, good afternoon, good evening from wherever you are. Welcome at another episode of the AI Talks Live.
Hey, my name's Akanksha Malik and I'm from Melbourne.
Excellent Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Tess. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akita Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Edi Daoud from Ghana.
Hi, I'm Anna from London.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi.
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 Hi. Hi.
Hi everyone, welcome back. As I said, welcome back to another episode of AI Talks Live. We're very happy to have another guest speaker, and today we're having Dmitri Soshnikov. Hi Dmitry.
Hello everyone.
How are you doing? How are things going over there? And where are you based? Please tell the people.
Well, I'm based in Russia. Everything is pretty nice here. Nice sunny weather, although it's getting a little bit late. It's evening.
Same here. Well, it's 7 o'clock now in Moscow.
Yeah,
it is. Cool. Dmitry, what is your day-to-day job? You work for Microsoft as a advocate?
Yeah, I work as a cloud developer advocate. It's, I think, a dream job because you can work with people and you can work with code. And that's why it's a little bit challenging, because I think most of the people who like to work with code, do not like particularly very much other people. But I have to combine both, and I think that's really fun.
Yeah, I can imagine. So how did it change a bit your job now? Because post-corona and pre-corona and current time, did you have to?
Well, for me, it was not much of a change because I was like in an international team, so I was working remotely anyway, quite a lot. Now I have to travel much less, but on the other hand, I think there are a lot of very nice opportunities with this situation, because you can do presentations remotely, even for not very important occasions. Like, for example, I was speaking to one university and one art school in France about the topic that I will be talking today, and that was just a presentation for students. I wouldn't have done it if not this situation. So
yeah, that's the cool thing. There's more virtual going on, so there's not any distance. Everything is just from home, so that's a good thing about it. So today you're going to talk about creating art with AI.
Right.
With that, I will just give you the platform. I'm looking forward to your talk. So I'm going to share your slides.
Excellent. Thank you so much. So it's really my pleasure to present this topic to you, because it's a little bit like non-traditional. It's not like a business-related talk. It's a talk about fun projects that I'm doing with Microsoft platform. So as I already mentioned, I work as cloud developer advocate. Before that, for a couple of years, I worked as software developer at Microsoft. We were doing some interesting AI projects with big companies in Europe and worldwide. I also teach at a couple of universities in Moscow, and one of my interests is how to spark enthusiasm in young people. And one of the reasons for that is my daughter is growing up. She is now 16 years old, and she goes to art school, and she likes to draw, and she also goes to math school, and she also happened to like mathematics. And my challenge has always been how to get her interested in computer science, in programming, and I started to think, how can we combine art and computer science? And that brought me to the area of science art, of this combination between art and science. And because I talk a lot about Microsoft AI services, the natural thing was to start and thinking, how can I use Microsoft services to create some kind of art? And you can see the result here. And that's what I will be talking about today. I will be talking about two examples of using AI for creating art. One of them on the left is called Cognitive Portrait, and it would use AI as a tool for expressing your creative ideas. And on the right is the generative adversarial network, pretty standard technique for AI producing art kind of by itself. And I will show how to create those pictures as well. So let's start with the first one, with cognitive portrait. And the idea of this cognitive portrait is actually pretty simple. We have cognitive services. Cognitive services are functions in the cloud that allow us to use pre-trained AI models to do something with some common tasks like object detection, object recognition, text processing, and so on. And in particular, cognitive services that can process images, they can do actually many interesting things. One of the things, they can just see the image and produce the result, like what's contained in the image. I can show you a very short demonstration on the Microsoft page of cognitive services. aka.ms/cogon is the short URL that I'm using to get there. We can see that all the services, and because we are interested in vision, I will show you the example of computer vision. In computer vision, you can try it right here from the web page to see how good the service behaves. You can see that it extracts a lot of objects in the picture, and you can even upload your own photograph. For example, this one, it would give you all the objects, all the tags, and it would give you even the description, the text-based description of what is contained in this image. It says Dmitri Soshnikov looking at the camera. I am always surprised how cognitive services of Microsoft know me by name. That's really surprising. You can try them for yourself as well. So that's on the right. You can see the JSON that a developer would get from this service. And one of the things that you can get also from the service called Face API is so-called facial landmarks. So you can give it a photograph, and it would extract those landmark points from the face. So if you want to create a kind of cognitive portrait that I have shown you previously, the idea is that we take several photographs and we align them together in such a way that they all coincide in some points. So, for example, we want eyes to appear at exactly the same position. So to create this cognitive portrait, we run the photographs through cognitive services. We extract the positions of the points, and then we apply so-called affine transformations to align the photograph in the right way. Affine transformation is the easiest thing you can do here because it does not like warp the image in any way. It keeps parallel lines parallel. So it just moves the photograph, shrinks it in different dimensions so that eyes become located in the right points. So you can imagine that if you want to get the resulting photograph of a certain size, let's say I want 300 by 300 pixels, then I can compute the coordinates of the eyes pretty much like beforehand. Like, for example, the coordinate of the eye would be 120 by 120 or something like this. So I can compute those points, and affine transformations, they are designed in such a way that they can be defined by 3 points. Like I need to specify 3 points, not on one line, and where they would move. So I can take 2 eyes, and I need one more point on the face which I would need to specify the location. So I can take, for example, the middle of the mouth. Middle of the mouth is not returned by the cognitive service, but I can calculate it by averaging left and right positions of the mouse and calculate this middle point. And this middle point, I would need to move to, again, predefined location on the image. This has a certain drawback because the proportions of the face would not be kept, like, like the face, if it's wider or not, it would be kind of normalized across all people. But yeah, on the other hand, the result would look kind of better because the face outline and everything would be aligned in a nice way. So I want to show you how this code works. And in order to do that, I need to run some Python code. What is the best way to run the Python code? I can run the Python code locally, like by installing everything on my computer. But if you wanted to repeat that, it would be a little bit more difficult because you would need all the combinations of libraries and there might be conflicts. So the easiest way is to run everything in the cloud, and there are two good options to do that. One of them is called Visual Studio Code Spaces, and another one is Azure Notebooks. And Visual Studio Code Spaces were called before Visual Studio Online, and now they were recently renamed. And also the similar feature appeared on GitHub called GitHub Code Spaces. The idea of Code Spaces is that you can have the developer environment in the cloud, whatever you do, not only for Python, like for any programming language. And you can do your development from the local machine as though you are working locally with that developer machine. And that's very convenient because if you think of it, like if you are a serious developer, probably you can spend time setting up your machine in the right way to work on your project. But if you, for example, want to contribute a few lines of code on GitHub, that would make a problem because you would spend a lot of time setting everything up. With Code Spaces, you can start, for example, from GitHub repository. It would it would create the virtual machine for you. It would clone the repository, set up the environment, and all that would happen pretty fast. And then you would be able to work with that environment pretty easily either from your local instance of Visual Studio Code or Visual Studio, Big Visual Studio, or through the browser. I can just quickly show you the demonstration, I think. Let me just, sorry about that. ak.ms/code spaces is the good way to get there. And here in the moment, we'll see that I have my environments already created here. And this environment is, in fact, it's a virtual machine, but all of the environments are suspended because they are set up to automatically suspend after 30 minutes of inactivity. So I don't have to worry about forgetting to shut down virtual machine that I'm using. And when I want to use it, I can just say, okay, I want to start this environment. And it would open up this environment, in this case, in the browser. I can also do the same from Visual Studio Code or from Big Visual Studio. I can just say I want to connect to the code space, and I would be working with a very fast and very convenient IDE on my local machine. But all the debugging, all the code would be started on the remote server in the cloud. And here, if I'm using the browser, you can see also the familiar developer environment because it's based on Visual Studio Code. Visual Studio Code, luckily, is web-based editor. So right here, I have all my familiar environment. And I can open like the Jupyter Notebook right here and start running the code. It would, because I have the Python extension, it would just reload in a second. And we would see the notebook, hopefully. Yeah. That's one way. Another way, as I mentioned, is to use Azure Notebooks. Yeah, here we have the example that I want to show you. I will also show you how to use Azure Notebooks as well. So the code that I'm about to show you is available on GitHub. It's github.com/cloud-advocacy/cognitive-portrait. So you can go there. And this repository contains different samples. Like the simplest one, which I have already demonstrated, is this one, when you just put all the pictures aligned together. But you can imagine that there are other possible ways to create art around the same idea of programmatically aligning pictures in a certain way. For example, you can align two pictures like that, like two sets of pictures like that, or you can even create the circles or do some more crazy things. And in this repository, I have also a contribution from other community members. Some of them are my students whom I give this task to do something crazy with pictures. And if you also want to experiment, I definitely encourage you also to create a pull request into this repository. There are a lot of different examples here already. And if you want to run this code, as I mentioned, the code spaces, you can clone the GitHub repository in the code space, or you can launch it in the Azure notebooks. There is a button which you can press, and it would say import. You just log in with your Windows Live ID, with Windows Microsoft account, and create the notebooks based on GitHub repository. And they would look like this. All the files from the repository, and you can open any of them and start coding. So here is the example. I will briefly go through the code to show how it works. So we start with installing some libraries. We need OpenCV here and Matplotlib. And then what we also need is Azure SDK for calling the Face API. That's also available as the pip installed library. Then to actually use the cognitive service, we need the key and the endpoint. And if you have access to Microsoft Azure, then you can create on your Azure portal the object called Face API and get the key and endpoint from there. If you do not have Azure, you can always request the free trial key. So for example, here, you can say, I need the trial key. Press get API key here and get your key for 7 days, which would allow you to process 30,000 faces. That would be enough to experiment with your family pictures. Once we have the code, we put the code here. The only important thing is that for endpoint URL, we need to put only the server address without the actual endpoint, because in the cloud and also in the trial page, you would get the complete endpoint URL together with /API /something, and all that rest of the URL we need to omit and just leave the server name here. Then to use the Face API, it's pretty simple. We create the client Face client object, providing the key and endpoint. And then with this Face client, it's pretty straightforward. We just pass the URL to this function call, and we get the facial landmarks as the result. We can also get, instead of landmarks, we can get, or rather, in addition to landmarks, we can get also some other attributes. Like we can say that we want to return face attributes equals to age. And here, face attributes, you can see that it also can detect the age of the picture. And by the way, the picture that I'm using here, let me show you that it's a real one from the internet. It's the picture like this of me at some conference. So now we need a bunch of images to work on. And in the repository, there is already a bunch of images of Bill Gates. If you look into images directory, we have Gates directory with like a number of pictures, or something like 50 pictures of Bill Gates obtained from the internet. If you want to run this on your own photographs, and I suppose many people would probably want to do that, then you just upload the photographs here into a separate directory and use them. Just specify different directory name. Then we run through, like here is the example of using the first photograph, actually not the first, but the third photograph from the set, which looks better. We can see how the points extracted by cognitive service looks overlaid on top of the face. You can see that the parts of the mouth are in fact detected, and eyes are detected, and all those, they look a little bit small, so maybe I can make the radius bigger. I think those numbers specify the radius for the circles which outline the points. So they would probably be more visible like this. Yeah, now they are definitely more visible. So now we need to call cognitive service for each photograph in the directory. So we do a small loop here. We call the face client for each photograph and create the array of image points. I will not do that because I have done it before the presentation, not to spend too much time now. You can see that for each photograph, we have the extracted images and extracted coordinates of facial landmarks. And here is the sample of how our images look like. Just let's wait a little bit while they show. And yeah, we'll see the first 5 photographs here. So next, I will continue talking while I think if there are some photographs which are of pretty high dimensions, then it takes some time to like align all the photographs in a nice way, and that's why sometimes it takes so long to print. Okay, so yeah, I will just continue at the moment. So next, we need to do the actual affine transformation. And as I mentioned, we want to align eyes and the middle of the mouth to specific points on the target image. So the target image size is specified here, 300 pixels. And the 3 points where we want to align to are specified in the target triangle. So we say that those are coordinates of left eye, right eye, and middle of the mouth. Yeah, here we can see the photographs. So now we compute to the function affine transform takes the image and takes the array of attributes, like array of coordinates of all points. So now we compute the middle of the mouth, like middle of the mouth is mouth left plus mouth right divided by 2. We compute x and y coordinates, and then we compute the affine transform. So this get affine transform, we pass the actual coordinates of points and the target triangle, and we get the affine transformation matrix. Affine transformation is defined by a matrix. This matrix is such that if you multiply the coordinate vector by this matrix, you get the coordinate, the new coordinates of the point after the transformation. So we computed this matrix M. And now what we need to do, we need to apply this transformation to the image. And there is, luckily, in OpenCV, there is a function which does just that. We just call varp affine, pass the image, pass the transformation, and also pass the bounding box. Because definitely when we rotate the image, some parts of the image may move to negative coordinates, some parts of the image may become too big. And then we want to cut this photograph in such a way that it would be bounded by 300 by 300 square. So that's why we also pass the coordinates of the final picture. And what we do next, we call the affine transform for each photograph in our list. If you remember, we got the list of images and we got the list of image points. We go through them and we call this affine transform function, and we get the array, the list actually of we get the list of transformed images. One more thing that I forgot to mention here, if you will be playing with it yourself, the free trial of cognitive services allows you to process not more than 20 images per minute. So if you try to process more, you would get an error from calling the cognitive service. So the way I go around here is I limit the number of pictures. I use only 13 pictures from my directory. It could be 20, but not more than that, because in this case, you can come to the limitation if you do not have the proper cognitive services key. But if you have it from your cloud account, then of course you don't have any limitations. You can go and process as many images as you want. So now I have processed images, and you can see that all images are in fact in the right position. So to get the final result, we just need to blend all of them together. And to blend all of them together is a very simple task in Python, because in Python, images are represented as tensors, and you just need one big NumPy array. You go and average it along the first dimension. I also have a little bit more complicated averaging function here, which can assign different weights to different images. Because what you might want to do is you might want to create the random compositions of images and select the best one. So that's why I added the possibility of adding some random weights. So here is the sample of how aligning two images work. Not very nice example, because the first face was picked up like I would not say wrongly, but because I pick up the first available face, and on this photograph, Melinda seems to be probably like bigger. Her face comes up first. So yeah, that's why we have slight disturbance. But if I average out all the photographs in my collection, probably that would not be visible anymore, and I would get the photograph of Bill Gates in this nice cognitive portrait way. And then you can produce some random images by adjusting weights and by trying out different combinations, and you can save the result. So that was this like interesting, simple technique. Yeah, you can see that different weights give kind of different experience, and you can vary the number of photographs that you want to mix together. Here it's 5. You can take more, you can take less. This example shows all 13 photographs all together, and that would all yield different results. And also, because we align everything programmatically, we can come up with more interesting ways to compose photographs together. For example, in this picture, which I called Growing Up, there are pictures of my daughter at different age ranges. So you can see on the left, she looks kind of younger, and then as we move to the right, she becomes older. And all that was created automatically. I just took the big number of photographs of her. I process them through cognitive services because they return me the age. I can group them automatically into groups, and then do the automatic alignment. So you can come up with different interesting ideas on what to do with those with this idea of cognitive portrait. One more idea that we have come up with is to create an interactive exhibit based on that. And here you can see the first prototype which we had. It's the system which it takes the photograph of people passing by. Whenever it sees that there is a face in front of the camera, it takes the photograph and aligns it together with 10 previous photographs. So you can see that here we are playing with it by putting different faces in front of the camera, and it blends them dynamically with other faces. And if you put this exhibit in the exhibition, which is something we actually did in Moscow, in one of the museums in Moscow before the pandemic, there was this exhibition where people were passing by and taking their pictures, and all those pictures were blended together and demonstrated back. So the architecture of this was the UWP application at the client side. And on the server side, there was a Python Azure function which blends together the photographs, stores them in the blob storage, and returns the result back to the user. And the interesting idea here is that because we have the cloud backend, we can put another installation somewhere else, like in different country or in a different museum, and we can blend together visitors of different museums. I think that is very nice artistic idea, because we in fact create something like this kind of teleport, photograph teleport, which unifies different physical locations. And we can go actually one step further, because now that museums are closed, we can provide this experience for people at home. They don't have to go to a museum. They can use, for example, a chatbot or web browser to upload their photograph, and this photograph would be blended with photographs of other people as well, using the same cloud backend. So in fact, yeah, we can use bot framework. I have given a talk at one of the Python conferences on how to create bot in Python, and then like the cloud backend and all this kind of exhibition experience. And if you want to try it for yourself, it's available in Telegram. It's called People Blender Bot. So you can just add this bot in Telegram and send it your picture, and it would give you back the blended version of this photograph with other people. So that was the first half of my the first part of my talk, and we saw that AI can be a really good tool for expressing your creativity, but you have to have the idea of what you want to do. Now, moving to the more interesting grounds, we can say that we can think whether AI can in fact create art by itself. And we know probably you know that there is a technique called generative adversarial networks. And I will show you briefly how they work and how you can train those networks on Azure Machine Learning service. So I have the blog post about that. So if you want to read it in more detail, or if you want to copy the code, it's all available online. I used Vicky Art dataset. So Vicky Art is the collection of art pieces online, and there is another project for downloading pictures from Vicky Art. So you can use that to get the collection of pictures of a certain genre. And then so the pictures look something like this. You can see the example of pictures of flowers. You may have some hard time like collecting pictures of people, because for pictures of people, I don't think they are classified in the right way. So I had to also run cognitive services through them to select pictures of people, and if I want to train specifically for portraits. So there is a little bit of Python code to select the good data sets to train the neural network on. And then the way generative adversarial networks work is by putting together two networks which would kind of fight against each other. First, you have generator. So generator is the neural network that takes a random vector as input, like just a vector of numbers. And for each vector, it produces the output of a picture. So this is something ideally we want to have at the end, a neural network that would paint the picture for us. We give it a random network, it gives us the random picture as an output. But like, how do we train this this network? To train it, we have another network called discriminator. It's also a neural network which takes a picture as an input. And the role of this network is to tell us whether this picture is real or fake, whether it's a picture by real artist, in which case it should return 1, or it's a picture produced by generator, in which case it will return like 0. Initially, both networks are not trained, but as soon as we start training them, discriminator learns how to better distinguish between those two kinds of pictures, and generator learns how to better generate fake images. And that's how this whole system works. So for training, I put together the small library for training GANs in Keras, which I called KeraGAN. It's available on my GitHub. And the architecture of the networks is the following. Like for generator, we start with a random noise, and we use deconvolutions to get into an image. If you know like how convolutional neural networks work, they work by like extracting filters, and extracting filters into the dimension of features. And here we start with the dimension of features, and we produce the image. And then this image is passed to discriminator. And in discriminator is the convolutional neural network. So discriminator takes the image and then convolves it to the feature vector, which we then pass to the classifier. So that's very normal convolutional network. And the generator is kind of reversed architecture of that. So if it comes to the code, yeah, you can see that that's how the generator and discriminator are produced. We have several layers. For example, in discriminator, we have the not three layers, but three sets of layers with different number of features. Each time we convolve with 3x3 filter. And for the generator, it's the same, 3 sets of images, but instead of like in discriminator, we reduce the dimension by doing average pooling. In generator, we increase the dimension by doing upsampling. So yeah, and the output of the network, the output of generator is hyperbolic tangent. So the images should be all in the range of -1 to 1. So the way we train those models is the following. We generate noise vector and we generate images. We use some kind of batch size, like batch size can be like 32 or something like that. We generate 32 random vectors. Latent dim is the dimension of this random vector. And for each vector, we produce the output. right? So we get the images. This gen images is the generated images which we predict, and images are real images. So we get the batch from our data set. So these images are real pictures, and GAN images are fake. Fake and real. So what we do next? We first train the discriminator. We set we train the discriminator by giving it the right answer. So we say that for images, for real images, it should return once, and once is just a vector of ones. And for generated images, it should return zeros. And we train. We train discriminator. And for we use for the loss, we use the average loss between those two training attempts. And then the interesting thing is how we train generator. We have the combined model. Combined model is like two of those models stick together. So it expects the vector as the input and the result as the output. We now say, okay, let this combined model. Let's train this combined model in such a way that it produces once as the output. You see, combined model uses fake images. But we say that we want to train it in such a way that ones are produced, so that real images, are indistinguishable images, are produced. And because we say in the combined model, we set discriminator to non-trainable, we say discriminator trainable is equals false. Discriminator during this pass is not trained. We only train the generator. And this improves the quality of generated images. Now, the challenge is to run this all in Azure Machine Learning. So I will briefly describe what is Azure Machine Learning. In Azure, there are a lot of interesting things for AI, but like you can do virtual machine and do everything on virtual machines. But normally, in the real life, you have many challenges. Like in the real life, you want to train the model many times. You want to observe the results, select the best result, and have all the experiments be reproducible. And to keep all that discipline, you need a lot of discipline if you are using just virtual machine. Here in Azure Machine Learning, all that is simplified because you have everything in one place. You have all your data like inside the Azure ML workplace. You can then define data sets on that data. You have the compute resources, which is a cluster or a virtual machine which starts up whenever you need it. You can have Jupyter notebooks inside the workspace. You have all the list of all experiments together with their results. You keep models in the same place, and then you also handle deployments there. So in the workspace, you just create the workspace. Let me show you how to do it from the Azure portal. The easiest way to create it is interactively from the portal, but you can also do it, of course, programmatically or through command line. So you go and you say that I want to create the machine learning portal. You give it a name, then you give the name for the resource group. And we select the location. And then there are a couple of pricing options, enterprise and non-enterprise. In our case, it doesn't really matter which one to use. And then we just go ahead and create it. Once we create it, in the portal, we go to the new Azure Machine Learning Studio. So with the workspace, we can access it through another kind of specific machine learning portal, which is being improved constantly, and that's it provides much better experience. So we go to this machine learning portal. First time that we do it, we need to select again the right subscription details. And here you can see all those elements that I described, notebooks, data sets are available. So the first thing we need to do to train anything, we need to create the compute cluster. So I go here, I create the compute cluster, I give it a name. I specify also, I can select between CPU and GPU. And I can select between dedicated and low priority VMs. So low priority VMs are virtual machines which can always be taken away from us. but they are about 5 times cheaper than the real ones. So it's always better to use low priority VMs because you save on training costs. But also like in when you have the cluster managed by Azure ML, it doesn't really matter, because if one node in the cluster is stopped, then it would just spin up another one. Of course, you might lose a little bit of your training, but depending on the way you structured your code, that's not very critical. So this cluster is called compute target. And if you want to run an experiment on this cluster, here is how everything works. You create the code on your computer, like you create the training script which would train your model. And then you call Azure ML and say, I want to submit an experiment. What it does, it takes the snapshot of the current folder and sends it to the experiment. So if you have some other Python files like libraries, dependencies, all that is packaged and sent to the cloud. In the cloud, a Docker container is created automatically. Like the first time you do it, it takes some time to create it. But if you repeat it, you use the same settings, the Docker container would be reused. So it would be much faster. So this container is stored somewhere, and then it is deployed to the compute cluster. Also, the data that you use, they are normally stored in the data store associated with Azure ML portal. So this data store is mounted to compute, like it's not physically copied. The data is not physically copied, it's just mounted, so it's instant. And then the script is launched. Our experiment starts to run. It streams all the logs and outputs and metrics to back to our machine, so we can see actually what goes on. And then once it's done, it stores the result. Like if you put anything in the special directory called outputs, and normally we would want to put the model there, and we would want to put the model or maybe some sample files. Everything is stored together with the experiment in the portal. And that's very nice because we have the complete control. Like even if later on we discovered that this experiment was the best one, we can always take the associated model and use it, for example, in production. So what we need to do, how we need to adjust our code, we might want to add logging to our training loop. So in our training loop, we can, at each epoch, we can predict, for example, 3 random pictures. We say that we generate 3 vectors, we generate 3 images using generator, and then we can plot it into matplotlib plot, and we can say run .log image. This log image, what it does, it takes the current plot and logs it to the experiment, so that later on we can see it through the portal. And so if we want to perform the training, the first thing we need to do, we need to upload the data set, and that's pretty simple. We get the reference to the workspace. I think I will not go into detail here, but briefly speaking, like to get the reference to the workspace, you need certain data like group name and subscription ID. And all those details, they can be taken from Azure portal. There is a button, download config.json file. So you download this config.json, you put it in the current directory, and then you can create workspaces just by saying workspace.fromconfig. So that's very easy. Then we create a reference to our cluster, and we upload the dataset. We say dataset get default data store and upload some directory in the local computer. So I put all the pictures, for example, of flowers or all portraits in a certain directory. I upload it to the Azure ML workspace, and then I submit the script for training. So I say, here is my script, train.gan.py. Train.gan.py basically contains the code which I showed you earlier, the code for training. And I want to start the script on the cluster using those parameters. And the parameters, essentially, we need to pass the path to the data store. And then we also specify the environment. So we need to say that we need certain conda packages, we need certain pip packages. So in our case, because I'm using Keragan library, I fetch this directly from my GitHub. And this is needed for correctly preparing the container for our experiment. And then I just say experiment.submit. This can be done like from my local machine. This can also be done from the command line by saying az ml and something. But I think Python version is kind of neater because you can specify all the details like which libraries, which versions, and that's much easier to do it in this way. So once you have run the experiment, you can find it in the portal. Here is our experiment. You see that the completed version took 11 hours to run. And in this version, in the outputs, you can see all the logged images as the model trained. So we can start with like the first one. The first one was pretty much a noise, random noise, because the networks are not trained. And then if we go deeper, we would see that the network starts generating something which remotely resembles like pictures, the way paint looks on the canvas. And then the more model trains, the better results it produces. Of course, I mean, we do not get nice picture each time we generate something, but out of like many examples, we can see some nice ones. And also because I'm storing models at each step, I have the discriminator and generator models for every step of the training, and I can download that and use it. So I can download the models programmatically once I have the reference to this run. Because when I start the experiment, I have this reference to the run. I can get this reference and call get file names. It will return me the list of all names. And I can programmatically find the generator model with the highest number. So that's what I do here. I select the maximum number for, essentially it's the largest epoch. I get this number and I download the model name. And then once I get the model name locally, I can call it to produce as many nice pictures as I want. So that's how you can train GANs on Azure ML. So the interesting question here, of course, is to which extent this can be called art. And I discussed this quite a lot with my friends from this from this area, and many people tend to agree that art is something which people value. And the way to know that people value something is by selling something at an auction. And there were cases when the painting produced by GAN was sold for quite large amount of money. It's quite a famous, in fact, case, and there are a lot of interesting details, like the code was taken from open GitHub repository, and then some other people trained it and got all the money, and the original author was a little bit disappointed. So it's an interesting story behind it. But to put the long story short, if people are ready to pay for it, probably it can be called art. And the next interesting question is whether this art was created by AI. And that's the question which is harder to answer, because it might look like the neural network did all the job. We just put the random vector and it produces the drawing. But on the other hand, human beings, first of all, we need to collect the data set. We need to select the best ones at the end. And by selecting the best pictures out of several thousands, we actually apply our human criteria to what is artistically pleasant, because AI by itself cannot, in fact, determine pretty reliably what is artistically pleasant, even though we train the discriminator and we select the pictures which correspond to high return of discriminator, but still they are not artistic enough for a human being. They can sometimes look like a random noise. So we need to apply this kind of human judgment according to what is actually art. And also we create a story, because the reason somebody bought this picture for a huge amount of money is that it's the first AI picture sold at an auction. So this is the story behind it, and people pay for the story and not for the actual paintings. So you can see that AI, what it does, because when you train the neural network, it learns, like convolutional neural network learns certain patterns. It learns how the low-level patterns, like how oil is laid down on canvas, all those canvas-like patterns. It picks up high-level patterns, like how different parts of an image look like, how eyes look like. And then what it does, it combines them together randomly. So you can see here is the example of portraits created by GAN. So in fact, it knows how the face should look. It knows the approximate composition of the painting. And then it combines those things randomly for us. and then we select the best ones. In a way, it's of course similar to the way human beings are learn to see, because when children learn to see, they also learn to fetch certain patterns from the surroundings, from the environment. But the important thing is that, of course, AI does not possess this kind of artistic ability to select what is good and what is not good. So to finish that, let me just show you a couple of videos of those images being created. And those videos I just sample the same vector over each epoch and put them all together in video. So you can see on the right, it's probably a picture of flowers, and on the left, it's a portrait. And it's interesting, in fact, to observe how the network tries to refine certain parts to slowly make it more and more similar to something that we might call a painting. Yeah, I find it always very fascinating to watch that. Unfortunately, to produce such a video, you need to spend 11 hours of GPU training time. But once you do, you have the generator, you can produce many more images. So if you want to more detailed discussion on whether we can call it art or not, I have the blog post about that, and the link is here on the slide. And I think that's pretty much what I wanted to talk to you about today. If you have any questions, I would definitely be very glad to answer. And if you are interested somehow in this, you can always come back to me. On my site, I have contact information, so you can always contact me directly later on if you want.
You have your own Instagram account where you show your creations.
Yeah, I have my own Instagram account where I show my food, and then I have my own Instagram account when I show the creations of the neural network, but not very often. My original intention was to, generate a lot of pictures and put out one picture a day. But as with all those projects, it never works out quite like you want it to be, because you need to remember to do that every day. But I try to do it once in a while. Yeah, I also try to make my daughter do it once in a while, but so far we don't cope very well. But you can subscribe to it, and we will do our best to put some nice good.
So if you have questions for Dmitry, you can ask it on YouTube chat, ask it on Twitter, on Twitch, or on Facebook, wherever you are watching. Then we can answer it. Dmitry, especially the first part, when you put the pictures on top of each other, I was like, how are you going to do that? And then you explain it as like, okay, it's that simple. Even just by explaining something, it's like, okay, then that's fine. And actually, I tried your bot, and I got this result.
Looks good.
So if people want to try it, you can. If you have what's the app called again? Telegram. You can find the bot called People Blender Bot. Just send in your picture, and it will generate another picture.
Actually, there is an easier way to try it. I have the web version on my site. It's called soshnikov.com/museum/peopleblender-bot. I think this link is not available directly, but maybe we can put it. Can I put it in the chat?
Yeah, you can put it in the chat.
It's like comments, right? How do I put it in the chat? I'm confused a little bit.
I use it in the private chat, and I will share it with everyone.
Okay, that's excellent. Yeah.
Someone from Russia who says your pictures are so beautiful.
Yeah, I have fans in Russia. That's not surprising.
I cannot pronounce her name because it's not in the characters I can read. So
yeah, Olga. Yeah, so here you have basically the same bot, because bot framework allows you to just embed the code here. So you can chat with the bot. It gives you the examples, and it tells you that please attach the photograph. So yeah, here you go and attach the photograph, and you get the result.
So now my picture would still be implemented in it somehow.
Hopefully. Yeah, but yeah, let's see if it's still visible, because it's 1 out of 10. I blend 10 pictures together. 10 last pictures. So if you send your photograph like 5 times in a row, you have something much more looking like you.
Yeah. Cool. It's a very interesting talk, Dmitry, really. I think it's something that people not always put together. As if you think about data science or AI, it's always to try to fix world problems, but this is using it in an artificial and a creative way, and that's really cool. And I think we'll see even more and more things like this, as we have, for example, AI that creates music. That songs, and even if you hear those songs, it's sometimes like, whoa, is this created by a computer? That you can't hear the difference anymore. So that's I think we're still, the future is gonna, I don't need to say it, open our eyes of all the things that are possible with AI.
Yeah, that's a very interesting time we're entering, because as AI starts creating like music, and it starts creating also like fake news, and then to distinguish between those fake news and real news, we need another AI, because human beings are not capable anymore of doing that. That's a kind of interesting world where AI would compete with AI, and
that's the dangerous part of the deep fakes, of course. Where in art, well, that's not really an issue, but yeah, people would still want to know, is it generated by a computer or by a human? But yeah, you will still need to print it out somehow. It's not like the AI will paint it on a canvas.
Well, yeah, we just need a robot to paint it on the canvas. That's not even complicated AI, I think.
No, true.
Yeah, interesting, yeah.
Okay, so there's no more questions. Dmitry, I thank you very much for your time, for a fantastic talk. People can still watch it afterwards on YouTube, not live, of course, anymore. If they still have questions, you can always get in touch with Dmitry through his Twitter handle, which is shwars. I think that's it. So
thanks a lot for having me. It was really a pleasure, even though it's a little bit challenging because you don't see the audience. But yeah, still, I hope that was useful, and I'm looking forward to any feedback if there is one later on. Cool. Okay, thanks a lot.
Thank you very much, Dmitry. So also next week we have another talk. We will have one of the co-founders of the Global AI community. We will have Wella Mains, who will be talking about FairLearn, which is it's been released on Build 2020, and he's going to talk more about that. So we're also looking forward to that. So with this, again, good morning, good afternoon, or good evening. Enjoy the rest of your day, and hope to see you next week. Bye-bye.
Bye.
Hey, my name's Malik, and I'm from Melbourne.
Excellent summit with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, Neighbor Test. I come from Spain.
I'm Prasant from California. 大家好，我是卢建辉。England by Netherlands.
I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Dmitry Soshnikov is African.
Hi, I'm Ana from London.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi,